Hi guys, this video is about one proportion z-tests. The goal of this video is to explain what is a p-value, what is an alpha, how do you write a one proportion z-test, and some basic calculator skills. So let's start with what is a p-value. Before we do that, let's think about what are you trying to solve here? So when you do a one proportion z-test, you are doing a statistic minus a parameter divided by the standard deviation of the statistic. So you're taking this statistic and you're trying to see how many z-scores is it away from what you assume the parameter to be. So what you're going to do is you're going to assume that this is the parameter. So you're assuming. So you're assuming p equals whatever. So if you assume that the null hypothesis is true and you take some sample, you're calculating with this z-score, looking up its probability, and you're trying to find what's the probability of your sample occurring given that this is true. And if this probability is so small, that means it's unlikely to happen. If this probability from a random sample is unlikely to happen, that must mean that this cannot be true. So the definition of a p-value is the probability of obtaining a result two or more extreme. So here is your result, and here's your more extreme, and the same thing for the less than side, that was actually observed when the null hypothesis is true. So one more time, if this is actually the null hypothesis and you think that this is really true, kind of like the video we watched in class, if this is really a fair coin, this has to be 50%. What's the probability of 6 tails occurring? Well, that's so unlikely to occur, this can't be a fair coin. So this can't be 50%. That's what a p-value is stating. So the p-value says when it's unlikely to occur. Well, what's unlikely to occur? What you might think is likely to occur may be different than what your friend does. So what we do is we set a set standard called the significance level. Alpha is going to be called our significance level. And the null hypothesis is rejected if it's less than this predetermined level. So this is the level that we're going to decide, like anything below 5% is usually our alpha, but anything below 5% we're going to say is not likely to occur. So can it occur? Yes. That's why we keep saying unlikely to occur. Can you get 6 tails in a row? Yeah, but it's not really likely to occur. So anything below this, we're going to say can't happen if the null hypothesis were true. All right, so let's try an example. A recent study published that 20% of the population is bilingual. Not many of your friends speak another language, so perhaps you believe the true proportion to be lower. You take an SRS of 300 U.S. adults and find that 48 speak a second language. Test the claim that less than 20% of the population is bilingual. All right, so we're still going to do state, plan, do, conclude. So for state, what we're going to do is the same as before. We're going to define our parameter, and that is the true proportion of, what did we say? Adults. Sorry, I'll try to fix that. Adults who speak second language. Now, the difference between a confidence interval and a hypothesis test is a confidence interval tries to estimate something, like how many people speak a second language. Approximately what percent of people, U.S. adults, speak a second language. But a hypothesis test tests a claim. So if you look at our problem, we are claiming that the study says 20% speak another language, but you're claiming it's lower. So that's what you're testing. So you're going to write that symbolically. So what we're going to write first is the null hypothesis. The null hypothesis is that there's no effect or no change. So if there really wasn't a change, the parameter is 20%, whatever the study had stated. However, you think that it's lower. So that means the proportion is less than 20%. And when you start a proof, you want to set a significance level. It doesn't matter which one. Typically, if the problem doesn't say it, we use 5%. So you're telling the reader, this is the parameter we're testing, and we're going to test, is it really less than 20%? the true proportion of people who speak a second language. All right, so the next part is the plan. And the plan is composed of 3 parts. Was the data collected at random? Is the data approximately normal? And is the data independent? All right, so let's go with SRS first. It says here that the US adults were chosen at random. So adults chosen at random. All right, and to check if, so we're done with that. So now to check if something's normal, we do n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10. Unlike a confidence interval, we have an assumption of what the parameter might be. So what we're going to do is we're going to use this for p. We're not going to use p hat. So we've got 300 times 0.2, which is 60, and that's definitely bigger than 10. And then 300 times the complement, which is 80, and that's 240, and that's definitely bigger than 10. So the distribution is, don't forget, approximately normal. All right, and now we want to make sure that we have enough people in the population that we can repeat this if we needed to. So the way we do that is 300 times 10 is 3,000 adults, which is definitely at least, this sample is at least 10 times the population. All right, so since everything worked, you said what you're going to test, you checked if everything worked, we're ready to do the problem. And the problem we're going to do today is a 1 proportion Z test. All right, so a 1 proportion Z test, so we're ready to do the problem, is the statistic minus the parameter divided by the standard deviation of the statistic. Okay, those values are all in your booklet. So to plug those in, I already figured out p hat was 48 divided by 300, and that's 16%. The parameter that we're assuming is 20%. And the complement is 80, and we surveyed 300 people. Okay, and when I do the math, I get negative 1.73. All right, so I want to graph that. Oh boy, that's really ugly. Sorry guys, it's the weekend. Okay, and so negative 173, so if this is the mean, we've got 1, 2, so 173 would be like right there. And remember that we're proving less than. So that means I'm going to shade that side. And then you would look that up in your booklet, and to save time, I've already done that. And I get 0.0416. 0.0416 is less than that standard we set of 5%. So the p-value is less than alpha. So we say reject H0. Remember the H0 was that you wouldn't write this here. Remember, this is in your state part. But remember that the H0 is that the parameter is 20. But you're saying that this is so unlikely to occur that that can't be the parameter. So this must be true. So let's write that out. I do, or if you want to be nice, we do have significant evidence. And you want to tell the reader at what level you tested at. So we did it at a 5% level, because if we had done it at a 1% level, then we would have got fail to reject. So it's always very important that you state your significance level. I do have significant evidence at alpha equals 0.05 that the true proportion of adults who speak a second language is less than 20%, okay? And that's a hypothesis test. All right, So this hypothesis test was testing that the probability was lower. Let's look at what it would look like. Same problem, but what if it said, I think that the true proportion of people who speak a second language has increased. Okay, that means you'd be testing a greater than problem. So everything would be the same. You'd still get negative 1.73. So we would go 1, negative 2. So negative 1.73. But when you're doing a greater than problem, remember you're shading this side. When I used to teach middle school, I used to say shade the way that that's pointing. So that might help you guys remember whatever way this is pointing, that's the way you're going to shade. Okay, so then you would look that up in the booklet. And when you look this up in the booklet, remember that 0.416. So this would just be 1 minus 0.416. Oops. All right. Okay, what if the problem said, I don't think that it's 20%. It didn't really say an inequality. Or maybe it said, I think that the percentage has changed. So you would do not equal to in that situation. So if you got negative 173, same idea. So negative 1, negative 2, negative 173. And when you say not equal to, you're just trying to prove a change. Maybe it got smaller, maybe it got bigger. You're not sure. So you're going to do both sides. It's called a two-sided significance test. Oops, that's a positive. Okay, and so that's the p-value for that one. For that one, it's 0.416. Because of symmetry, that's also 0.416. So the p-value would be 0.4 plus 0.4, which is 0.8. Okay, and before I let you go, let's try the calculator. All right, so getting at your calculator, you're going to go to Stat, Test, and we're doing a 1 proportion z test. Okay, p sub 0 means what is your p at h naught? So what's your parameter? So we think it's 20%. X is success, so we think 48 people, excuse me, 48 people spoke another language in our sample out of 300. And in our original example, we thought that the probability was, or the proportion was lower. Okay, so once you've set up the screen, you're going to go to calculate, and that's exactly what we got when we did it by hand. All right, so I hope that helps. Good luck studying for the test, and good luck with 1 proportion z tests.